Good afternoon. The last time we covered the chapter on what is denoted as a source term. In that case, we identified the different radioactive isotopes that are released in a reactor accidents. We identified two categories or two groups. One was short-term isotopes. So short-term isotopes are of great concern because they have a short half-life, hence in the denominator for the expression for the activity, they are, thank you, disintegrating at a very high rate, hence they deliver lots of energy to the organs of concern. And in that case, in the short-term isotopes, we identified primarily the iodine 131, 132 isotopes that are descendants of another isotope, the tellurium isotope. And in that case, we worry about the iodine, of course, seeking the thyroid gland. And if it emits radiation there, it ends up creating what's called the thyroid nodules, which are little cancers in the thyroid. Paradoxically, to cure those cancers that could happen in the thyroid gland, we use radioactive iodine, give it to people, and then in that case, it goes again, it seeks the iodine and the potassium like to seek the thyroid gland in our neck, like a butterfly here. You can feel it. And in that case, they kill the cancer. So this is some kind of paradoxical in nuclear applications. Another category of radioactive isotopes were the long-lived isotopes. We identified two of them, the strontium-90 and the cesium-137. Now, once we deal with those radioactive isotopes, we find ourselves having to deal with two other issues. First, what are the radioactive isotopes that generate the decay heat or the after heat, which we know is characteristic of nuclear power plants in the sense that in a car engine or in a fossil fuel power plant, once you stop injecting fuel into the engine, the reaction stops. Not so in nuclear reactor applications because we have to deal, especially when we deal with solid fuels like we have in existing reactors, we have to take care or account for the decay heat generation from emissions of beta particles as well as gamma rays, and that's what we call the afterheat. If we fail in cooling the nuclear reactor for an extra 24 to 48 hours, even if you shut down the main chain reaction, you'll find that enough heat is generated to melt the core and cause a major accident. If you melt the core, you release the radioactivity to the environment. So this sends us into two directions now. One, to check what is a decay heat issue. And second, since radioactivity is released in reactor accidents, we'd like to see what do we do for the remediation of the release of radioactivity if reactor accidents happen. I like to mention that our choice today with using solid fuels is not really the only option that we have. We could have avoided the 3 Mile Island, the Chernobyl accident, and the Fukushima accidents, which all happened because of the decay heat or the afterheat by substituting the solid fuel that we use in nuclear power plants by a liquid fuel. If you use a liquid fuel, you can continuously extract those fission products from the coolant stream. In that case, could be a molten salt rather than a solid fuel in the reactor core. And you wouldn't have had those three accidents, except that the nuclear industry is not really adapting to new conditions. It's not innovating. And the innovation is really to switch from the solid fuels to the liquid fuels in the same way that in the First World War, Winston Churchill switched the fuel supply of the British fleet that ruled the world at the time from using coal, solid, and they would have basically people had to shovel the coal, the solid, into the boiler he replaced it with petroleum as a liquid, and it's easier to deal with. So in that case, this is some innovation and some evolution, in fact, that is needed for the nuclear industry. So it is not the end of the world. Sometimes people will understand that, and that evolution that's necessary will occur. In fact, China is building apparently a pilot plant with the help of Bill Gates, who has accused the nuclear industry of lacking innovation. His company that he set together in the state of Washington, in the city of Seattle, Terra word, something along this line, Terra Power, tried to build one of those liquid metal molten salt reactors, and he was not allowed to do it in the United States, so he went to China. China accepted the offer, but the United States would not let him collaborate with China, supposedly to keep industrial secret in the United States. So of course, total nonsense, because the basic concepts of molten salts are very well known in the open literature. There is nothing secret about it. All right, so let's look today at one of those two chapters that we have identified we need to cover in more detail, and that would be the remediation of reactor accidents. I lost. I don't know what happened here. Okay, here we are. I'm still not finding our. Here it is. So again, we have those two chapters to cover. Let's pick one of them and then go to the other one. So chapter 10, the environmental remediation of radioactive contamination. Let's cover that one today and then leave it for Monday to cover the decay heat generation from those fission products that we identified in the source term. All right, so how did we learn about the contamination of by radioactivity from nuclear fission? And we learned about it after, of course, the tragic events of Fukushima, of Nagasaki and Hiroshima. And the United States Navy in particular became very worried about another attack on a fleet of ships harbored in a harbor. In that case, it was the harbor of Pearl Harbor in Hawaii. And lots of testing went on. Some of the testing happened here in the United States. The first test, of course, was in Alamogordo, New Mexico, July 16, 1945. But since then, 2,056 nuclear test explosions have been carried out. And initially, they didn't know about the effect of nuclear explosions in the atmosphere. So they are conducted in the atmosphere, not just from the United States, but that was followed by the UK as well as France, and then the old Soviet Union. Then some of the explosions happened here in the continental United States, in Colorado and in Nevada. And but many of the testing happened in the Pacific Ocean, in the Marshall Island Atoll. I'll describe to you an atoll later on when I'll show it to you. It is basically a ring-shaped island that basically occurs in the Pacific Ocean in particular. There aren't many in the Atlantic Ocean, interestingly enough. And those atolls are used by fishermen. It's islands made out of reefs of basically plants that those atolls are used by fishermen because they provide them protection from the winds, the high winds in the ocean. So it's really a harbor for their boats. And we'll see how it affected us later on. The French carried their testing in the Sahara Desert in Algeria. That was one of their colonies. But they also conducted tests in Tahiti, one of their, an island that they control in the southern hemisphere. So the only tests happening in the southern hemisphere, what happened happened in Australia by the British, and in the island of Tahiti by the French. The nuclear weapon tests of the United States occurred between 1945 and 1992 in a period that was a nuclear arms race between the United States and the Europeans, nations, and the old Soviet unions. The United States conducted about 1,054 nuclear tests by official count, including 216 that were up in the atmosphere. And unfortunately, that released to the atmosphere a large amount of those fission products, primarily the long-lived fission products, what we mentioned last time, that was the strontium-90 and the cesium-137. It was discovered that in Europe, those isotopes concentrated themselves in populations of wild animals, deer in particular. And when people discovered that, the nuclear testing in the atmosphere was banned. But some contamination did occur very seriously when the United States conducted tests in the Marshall Islands in the Pacific Ocean. There was a contention about the Marshall Islands between Japan and the United States. The Japanese occupied it, the United States came in and reoccupied it again. It's a set of small islands shown here in the Pacific Ocean, I would say northeast of Australia and southeast of Japan. Some of those islands are islands and some of them are the atolls, and we'll see what happened in that testing in those islands. You could see here that some of the islands in those are some kind, take the shape of a ring, and in that case it's named an atoll. This one here, you could see it looks like a ring. It's called the Bikini Atoll, and some French basically fashion designer adopted the name and named it after a swimming suit for ladies. So we have the bikinis named after that Bikini Atoll. This shows us here one of the tests that were conducted in that Bikini Atoll. Now, you notice that there is another atoll west of it, that's Inuitak Atoll. The test was conducted in the Bikini Atoll with people from the weather forecasting people thinking that the fallout means the radioactivity from the test. It was an atmospheric test that the wind will blow from east to west. But as you could see here, that didn't happen by mistake. The wind blew from west to east. And in that case, the fallout or the radioactivity, these are the contours for different doses of radioactivity, fell on other atolls and islands and unexpectedly, and those islands were inhabited by people. So people were affected, and not some, but a major amount of radioactivity really settled on those islands. And we know that in the fallout from those atmospheric tests, you would get that cesium-137 and the strontium-90. So we'll see what happened in that case. In fact, the cesium-137 made those inhabitants remaining on those islands unfeasible, because they would have received a very large dose of radiation. So they were removed and taken to what was not, unfortunately, islands. They put them on an island like the Kili Island, the Lib Island. And the islands do not provide fishermen with protection from the wave. In the same way, if you have a coral reef, which forms the atoll. So they couldn't make a living. And they, of course, not being able to make a living, they demanded that they return back to the Bikini Atoll. They returned them, and then the radioactivity was still very high. They had to take them back and forth and compensate them for a great, great harm that was done to them. And the test that was carried at that time, if you want to read more about it, is named the Castle Bravo test. That happened in 1954. So the islands in that case were contaminated with large amounts of that nasty cesium-137. Now remember, we said that cesium-137 in the periodic table of the elements is right below the potassium. And of course, you know that plants need potassium as a fertilizer. So even if you have coconut trees that would grow there, or any plants they were planting, they became contaminated with that, the cesium-137. And basically, they had to go and scrape all the topsoil in the ground and replace it with soil that was chipped all the way from the United States to those islands, so that they can remedy. And that's the topic of our program, of our chapter today. The United States conducted a nuclear testing program from 1946 to 1958. They detonated 67 fission and thermonuclear devices. They had a yield of a total of 108 megaton of TNT, million tons, not kiloton, like the Fukushima, the Nagasaki and Hiroshima devices were in the range of 10 to 20 kiloton of energy. That's megaton, meaning that they are 1,000 times, actually 10,000 times as much energy release when they use thermonuclear weapons in general. The first thermonuclear detonation happened in 1952. That was thermonuclear, meaning that it was a hydrogen bomb, if you want to call it this way, because it used the two isotopes of hydrogen, deuterium and tritium. And it was a DT fusion reaction in that case that was generated. And that first test was named the Mike shot. One of the devices was named Shrimp. I'll show you a picture of it in a moment. As our testing happened, of course, in the Nevada test site, eventually it was sent underground by a treaty, and then another treaty banned totally nuclear testing underground or in the atmosphere. So nuclear testing now happens on supercomputers as a way of maintaining the stockpile. They call it the stockpile stewardship program in that case. So the Marshall Islands were disputed between Japan, they're close to Japan, and the United States. And there was fighting between Japan and the United States in the atoll of Enewetak, Majuro, Mili, Kwajalein, and Wotski in 1944. And basically, 3,000 American troops lost their lives, unfortunately, and 11,000 Japanese also lost their lives. So that was regrettable, considering that Japan and the United States are good friends today. So why did they fight in the first place? This is a view of the Bikini Atoll in the Marshall Island. Obviously, you could see the waves here coming to the beach. Right now, it's some kind of a tourist place. People go there as a tourist attraction. But as I suggested, when the weather forecasters made a mistake, the wind, instead of blowing to the vast open ocean to the west, it blew to the inhabited islands to the east. The radiation level was so high that the people at the Bikini Atoll in particular were relocated to the Kwajalein Island in that case. So you could see here a very tragic situation of relocation happened in that case. And you could see here, let us start with the Bikini. Bikini is here, that atoll. In 1946, they relocated to an island, not an atoll. So they're fishermen, so they couldn't live there because they have no protection for their boats against the sea. So they relocated back again to Kwajalein. That is an island again, it's not an atoll. And then they kept relocating them back and forth. For instance, from Bikini, some people were taken to the Healy or Kili island in 1975 and no, 75, yeah, and then relocated back 1975. All these arrows show you how people tragically have been moving from one place to the other, escaping the contamination with radioactivity. One way of remediation against radioactivity when there is a contamination is to replace the topsoil and saturate the topsoil with, in the case of cesium-137, with potassium, since we said that potassium and cesium-137 are in the same column in the periodic table of the element. They behave in the same way. So if you saturate the soil with potassium as a fertilizer, the plants prefer to uptake the potassium rather than uptaking the cesium-137 as one way of dealing with the situation in general. The nuclear testing in the Marshall Islands initially was considered something like as a curiosity for people living in the United States. You could see here naval admirals. This is Mr. Admiral Langley and his wife, Mrs. Langley. And they're inaugurating one of those testing. And you could see here the cake in that case is made to look like a mushroom cloud from a nuclear explosion. And not only that, but Mrs. Langley herself has a hat. It's funny in a way that looked like a mushroom cloud too from a nuclear explosion. So that was some kind at the time where the effects of nuclear testing was not known. This is a picture of the Able test. That was a device that was exploded underwater in 1946 in the, I think in the Bikini Islands, atoll, I should say, not an island. It is not an island, it's an atoll. And they had ships positioned there to see what is the effect of an underground explosion on ships that are moored in a harbor. So that was the fear of a repetition of the Pearl Harbor attack in general. You could see here the destruction that happened to some of those ships, not by direct hit from the nuclear explosions, but by the generation of a surge in the water, almost like a tsunami that you could see here. It did not just destroy the components of the ship that was too close to the explosion, but it also irradiated with lots of radioactivity. That is again in 1946. Nobody in this room was born, including your instructor in that case. It shows us here the fleet that was gathered in that Bikini Atoll to test it against attacks by nuclear explosions. They gathered 96 ships that were decommissioned or mothballed from the Second World War, American ships, Japanese ships, and even German ships, 96 a total of them. And as you could see that they tested for whatever damage happened to them, and they tried to answer the question of whether they can decontaminate them. Obviously, the ones near the explosion really are unsuitable for any kind of revival in general. If you look very carefully at that picture, you could see that the underground explosion basically rolls the water out from the lagoon. In that case, the lagoon is the area within the atoll, and you could see here those 96 ships as simulating a harbor kind of fleet moored in a harbor, and then that water that rose up fell down, and you could see here it created a surge in the water, and that is really what caused the primary damage. Again, another picture of that event where the ships are moored here and the explosion happened underwater. It was not a very high yield explosion. It was only about 20 kilotons, the same yield as the explosion on Hiroshima or on Nagasaki. However, it shows us here what I mentioned, the coral reef made atoll. Do you see here, if you follow the arrow here, do you see the arrow here? So this is basically the form of an atoll. Someday maybe you can go and visit one of those atolls. They're tourist attractions now. And as you see here, the open waters are on the outside. So the what is inside the atoll is named the lagoon. And the lagoon there is protected against the high winds and the high waves out in the ocean. So it's ideal for fishermen to harbor their boats, and then they can go out. There is an exit to the high seas to go and make a living getting the fishing. So in that case, the inhabitants of those islands were basically not able to conduct their livelihood in terms of the fishing, and they have been, as I suggested, relocated several times. So it was only 21 kiloton of TNT equivalent in the Bikini Lagoon. That's another picture of it. And if you could see the picture on the stem, here is another picture that shows how the water rose up. This is a mothballed ship here, another one here. You could see that when that water falls down, after it rises up into the sky, look at the ship here. It has carried the ship upside down. It has simply totally drowned it in that case. They tried to decontaminate some of the ships that were not sunk. And you could see here that they got boats and they got hoses to try to clean up the contamination. We are talking about contamination. In that case, the explosion would have contaminated them with some of the plutonium isotope that are used for the triggers, or actually the whole device, 21 kiloton, would have been plutonium, big failure. So in that case, the ships were totally decommissioned and they had no use at all. Other operations I described to you is Operation Sandstone. And one particular interesting testing was what's called the IV mic test. Now that was a test that was supposed to test not a fission device, but a thermonuclear device, meaning that it used thermonuclear fuel, deuterium, and tritium. And the fascinating thing, of course, is that it's not the 21 kiloton that we mentioned earlier anymore. Wow. They calculated that it would generate a yield of 5 megaton. And in that case, they used deuterium and lithium-6 as an isotope where the fission reaction produces neutrons. It interacts with the lithium-6. It produces tritium and with the lithium-6, and then the lithium-6 with deuterium generates a fusion reaction, a DT reaction. That one produces 14 million electron volts of neutron energy that can fission another third stage in the explosion, fission, fusion, fission of uranium-238. They made a big miscalculation, and instead of getting the 5 megaton of calculated yield, they got 10 megatons, 10 million tons of TNT equivalent. TNT is tri-nitrotoluene high explosive. And that is a picture of that IV mic test. You had a fireball the size of 1 mile or 2 miles enveloping the whole island where it was tested. Here is another picture. The IV mic test mushroom, October 31st, 1952. That was the one that was miscalculated, and you'll find that it was a very large device. Notice those people standing right next to the device. This is something that you cannot even put on an airplane. It was huge. So they had it on a barge, and the barge was exploded on the surface of the lagoon. It weighed 43,000 pounds, and that's quite a high weight. And this shows us the device that was used at the Castle Bravo test. You could see it's a long, very large cylinder. This side here would contain the fission trigger. So that would be plutonium maybe device that explodes. It generates radiation that affects now the thermonuclear part. In that part of the device here, the long cylinder, it contained, in that case, lithium-6 deuteride. What they didn't know is that they didn't need actually to use lithium-6 or separate lithium-6 from lithium, because lithium has a larger number or larger abundance of the isotope lithium-7, and there is a nuclear reaction that happens between the neutrons and the lithium-7, and that is one of the causes for the double size of the nuclear energy release that was miscalculated. They didn't need to enrich in lithium-6, just plain lithium would have done the job, but there was an excess release of energy that was totally miscalculated, and that was in 1946, March 1st, again in the Bikini Atoll. So that was miscalculation. In fact, I described how that was happened. That nuclear testing was based on total ignorance about the effects of nuclear explosions. You could see here, they asked some of the personnel to sit down and watch a nuclear explosion happening here a few miles away. Their only protection was to wear those ski goggles to protect them against the ultraviolet radiation. You know, if you go skiing, you wear those goggles, they protect you against solar radiation, the ultraviolet in particular. So you could see them here subjected to the light emission from an explosion, but that's not all. That light emission is followed by ultraviolet. Yeah, it protects their eyes here. They had also neutrons, and they had gamma radiation. They had X-rays. So those people were unnecessarily exposed to radiation, and many of them, of course, suffered from it, from cancers later in life. They thought that they can recover from a nuclear explosion by decontaminating the people that are close or are exposed to the fallout. Fallout is the cloud of dust and water or steam that prevails after a nuclear explosion. So here they're trying to decontaminate those people, clean up their dresses, but definitely they have been exposed to unnecessary levels of radiation. We said that some of the fission products that are emitted from nuclear explosions are emitting both gamma rays and beta particles. And this is one young Rongelap, one of the islands there, that was exposed to the fallout. The fallout would look like almost like snow falling from the sky. And in that little young kid, he survived, he didn't die, but you could see that the beta particles burned his scalp here. And that's the reason why they were relocated out of the island. Some of the, they walked barefooted here, and they had sand on their knee and under their armpits. You could see here, and on the face. So the fact that all those people here, the kids playing in the sand, were exposed to the radiation, particularly the cesium-137 and the strontium-90. So all that population that lived on those islands had to be relocated from the results of the explosions. Something interesting that happened along this line of nuclear testing, which really was at a time where the knowledge about nuclear effects was not known, is what's called Project 4.1. And that happened in another island in the Pacific that was built out of basically sandbars. China in the South China Sea has been doing the same thing. They would gather sand and create sandbars, and then that becomes a whole island. As a result of the Mike test, the radiation, as I said, did not go west, but went in the wrong direction. It went east. And in that case, there was a Japanese ship, the Lucky Dragon, the fifth Lucky Dragon, Daigo Fukuryu Maru. And people on the, it's a tuna fishing ship. One of the mariners or the crew on it saw something falling in the sky that looked like snow. And snow would not happen in the middle of the Pacific Ocean. It was really radioactivity or the fallout from the test. So one person died in that case, unfortunately. The tuna was taken to the markets in Japan, and then when they realized that it has been contaminated by the fallout, it was taken out of the market. But that Fukuryo Maru ship now is in a museum, preserved as some kind of a remembrance of the event that happened in that case. Some newly declassified material that people didn't know about was that there was an American ship also. This was an observation ship, the Curtis, and you could see all the crew there of the ship on the surface of the ship that was monitoring the explosion. So that is a Bravo test that produced twice as much energy as they calculated. And at some point, they were even worried that the test would ignite the atmosphere of the Earth and turn the Earth into a star. So in that case, fusion would happen between the nuclei of nitrogen. And you know that we breathe, 70% of the air we breathe is nitrogen, and the 15% only is oxygen. The yield of the explosion being so large, they had an observation post here in bunkers, and the people in the bunker did not were subjected to the shock wave from a yield that was double the expected yield. The fallout started falling on them. They had to also relocate them through helicopters, and they simply used blankets and bedspread sheets over their head to prevent themselves from being exposed to the radiation. The crew of the Curtis ship also was exposed to radiation. These were evacuated using helicopters. So these are some of the accidents where contamination happened very seriously. And that is the IV Mike test that was conducted in 1952. Notice the shape of the atoll here again. You see the atoll because it affected the relocation events. You could see its coral reef forming a ring. On the inside of the ring, you have a lagoon. The high winds and the waves from the ocean do not affect the lagoon, so it's an ideal harbor for shipping, for fishing boats in general. That's another test conducted in June 1956 at the Enewetak Atoll. That in the first map that I have shown you, it was west of the Bikini Atoll. But this shows us a picture of what an atoll is. What's unfortunate is that they didn't know about the difference between an atoll and an island. An island is subject to the high waves from the ocean. So those people who made their living fishing in the ocean could not use their boats living on an island, and that's why they had to be relocated upon their demand. This is what's called the Romeo test. That one also released 11 megatons, 1,000 times what was released in the Hiroshima and Nagasaki accident, and that happened in the Bikini Atoll too. So that Bikini Atoll was subjected to lots and lots of testing in general. One of the effects of those air explosions, if you want to call them, is that they noticed the generation of those thyroid nodules that I mentioned last time. The thyroid nodules would result from iodine 131 and iodine 132 seeking our thyroid gland, and then they, of course, cause small cancer. So this was reported in the people on the Rongi Lap island. And of course, people in that case had to be compensated. So the United States Congress gave them a compensation of about $11,000 per capita, per person only, which is really peanuts in terms of the damage that was caused to their livelihood. And I think until now, they're still arguing about some of the legal aspects of this compensation in general. As I suggested, some people of goodwill tried to decontaminate the system, and Chemically, as I suggested, that's something we need to remember, is in the same column of the periodic table as the element of potassium, and hence it mimics it chemically when ingested by plants like coconut trees and animals as well as humans. So the increased body burden of cesium-137 in the bodies of the bikini residents led to that relocation a second time in 1978, and they started returning back again in 2003 when the level of the cesium-137, because it decays, it has a half-life of about 20 to 30 years, was going down in general. So lots of remediation effort, as I suggested, has happened, and they were given compensation, but nothing can be a compensation for having them leave their home. And the process, if you want to read more about it, is still being litigated, meaning that it is still in the court. People there did not get enough compensation for the damage that was caused to them. Luckily, though, nuclear testing in the atmosphere as well as underground by international treaty is banned right now. There are recommendations about the levels of radiation that is recommended by the International Atomic Energy Agency. And in that case, the drama is still continuing. Now, people at that time are starting to die, so it's now their children, grandchildren involved in the litigation or the legal aspects of it. Some other aspect of the testing in the Hawaiian Islands is an island that's called the Johnson Atoll. In that case, they tested there not just nuclear devices, but they also tested biological weapons and chemical weapons, all the panoply of weapons of mass destruction, chemical, nuclear, and biological in that case. And I'll show you a picture of the island, and then you can read more material about it. It is part of the, it's a Johnson Atoll, as it's called. This is the atoll, but Johnson Island is this island here. It's an island that had just one single airstrip. You see here the island with a single airstrip, and in that case, it's an island. It's not even an atoll. And the island was formed by scraping sand and basically building the island out of sand in the middle of the Pacific Ocean. And they tested there very dangerous devices, biological weapons in that case. They would get a plane, then they spread the biological agent to a large area and make sure that it is not affected by the ultraviolet and solar radiation. And they also tested chemical weapons. It was very far away from people. And you notice here the American Secretary of State, Collins Powell, gesturing there in the United Nations with a little vial of what he called, what was used basically as an excuse to attack Iraq, the Iraqi war, suggesting on the basis of lies, actually, it was major lies, that the Iraqis were developing weapons of mass destruction, biological weapons in that case. There has been lots of controversy about what he held in his hand there, lying to the whole world. It was either pollen as a way of disperse the biological agent, because pollen, of course, floats in the air. You could see it float from pine trees in the spring. Some people say it may have been ground wool, and some people say, oh, it was just dried chicken blood. And he's lying to the United Nations here in that picture, basically made him appear, he lost his credibility, made him appear as a liar person, not honest person. And in that case, it may have cost him a run for becoming a president in the United States, because he was basically a person of integrity other than this nasty act that had to do with the Johnson Island testing in general. So the Johnson Island now is not being used for testing. It has been turned into a nature park where wildlife, geese, for instance, or in the Pacific Ocean find their way of way of retreat from the vast expansions of the ocean itself. So in terms of chemical weapons disposal, you know that chemical weapons, biological weapons have been banned from the world, and it's the only weapons that the nuclear weapon state have not been using. So you find here that it was projectiles of steel, the blister agent, GP nerve agent, VX nerve agent, were all in projectiles. They have been decontaminated, and something of interest, those shells have been melted and exported to other parts of the world. So the shells, steel shells, have been turned into maybe the steel used in some cars. So we may drive cars that are made out of those decontaminated shell. All right, before we forget, this is the worst case of contamination by nuclear radiation in the world. But there have been many other events that happened. One of them was the Kishtim reprocessing plant in the old Soviet Union. They basically were putting the waste in a large lagoon or a pond, and somehow an explosion happened and caused really the spread of radioactivity. It seems that whatever waste they're dropping into the pond became supercritical and exploded, and we have learned about it after the fall of the Soviet Union. In the United States, there is an area that's highly contaminated. That's a Hanford site in the state of Washington. This is one of those reactors there were 6 of them, A, B, C, D, that were producing plutonium, and they used the state of Washington along the Columbia River for cooling of the reactor. They are producing plutonium and then tritium for the nuclear program in the United States. Another contaminated site, obviously, is the Chernobyl accident site. The area around Chernobyl, now in the present day Ukraine, has been turned into a nature preserve, and it seems that wildlife is recovering very nicely. Why? Because we worry about that cesium-137, and 40 years after the accident, then most of that radioactivity has dissipated, except for maybe some plutonium still left, and it's being monitored. There has been accidents with bombers crashing. This is a bomber that crashed off the coast of Spain, and it has several thermonuclear weapons in it, 4 of them, and the weapons were retrieved from the bottom of the ocean, but one weapon fell on the ground and they had to scrape all the ground and put it in large 55-gallon drums. You could see them here, and ship them back to the United States. So there is an effort that's ongoing to decontaminate the nuclear testing site, and one of them here is shown in the semi-Palatinsk weapon testing that the Soviet Union, where the Soviet Union was conducting tests in modern-day Kazakhstan. No tests are being conducted, but look here, what is left from these areas. They are still in bad shape. This is parts of the Nevada desert in the United States have been used for nuclear testing. You could see here, this is an artillery shell that used a nuclear device in 1953. The French, as I said, carried out testing in the Sahara Desert in Algeria. It was one of their colonies before they gained their independence. And what you see here is in Arabic, khatar. And khatar translates into dangers. And the A and the N and the E and the R have been stolen, maybe the metal in it. And it's an area that is just surrounded by some barbed wire. But this is where the French conducted their testing, and this area is still contaminated in that case. France carried out testing in the Fangatofa atolls in the South Pacific. So this is the only testing other than one test by the British in Australia in the Southern Hemisphere. So we still have in the upper hemisphere strontium-90 settling down to the ground. This is the Indian nuclear test site in the Thar Desert in Rajasthan. And you could see how it is left needing to be decontaminated in that case. Another contamination with radioactivity is the areas where uranium mining is being conducted. So this is an area of Germany. It's basically a uranium mine with settling ponds, and that area is definitely contaminated. We don't know what they're doing to it. So how do we decontaminate an area that is contaminated with some of the fission products, primarily cesium-137? Basically, the remedy is a periodic application of potassium fertilizer that would be uptaken by plants instead of, say, uptaking the cesium-127. Another method of the contamination is a complete removal of the soil. And guess where they brought it? They brought it here from the Bikini Islands to the United States, and it was basically buried here in the United States. And I'll let you read the rest of the chapter yourself, but indeed, we are still living with areas that need serious decontamination. Last time we'll finish that chapter, but we'll stop for here for today and wish you all a nice weekend. And thank you for